3.6, number 244. We're supposed to find equation of the line normal to a function. In this particular case, it's g of theta is sine squared of pi theta at the point 1/4, a half. So you can verify that 1/4, 1/2 is on this curve. If you put 1/4 in for theta, for the independent variable, you'll get pi on 4 in here. Sine of pi on 4 is root 2 on 2, and squaring that would give you, of course, 2/4, which is 1/2. So certainly that point's on there. And let's show what a normal line looks like very quickly. So this is not our curve. This is just some arbitrary picture. There's some function f of x. And if I pick this location here to examine the tangent line, then it might look something like this. Here's our tangent. So if that's the tangent, then this would be the normal. So the normal line is perpendicular to tangent. Okay. Normal line is perpendicular to tangent line. Therefore, slope of normal line is the negative reciprocal of the slope of the tangent line. All right, so that's the main feature we need to know if we're going to construct a normal line to the use of derivative. Once we take the derivative, we'll have the slope of the tangent line. If we just find its negative reciprocal, we'll have the slope of the normal line. And then we can still use the exact same point, right? They all share the function, the tangent, and the normal all share the same point. And we can plug that point in and then find the y-intercept. All right, so to find g prime of theta should be, all right, so this is another 3 links in this chain. All right, there's 2 connections, 3 links. You've got the most inner thing, which is pi theta. That's being put inside the sine function. And the sine function is being put inside the squaring function. So the squaring function is most outer. Since the squaring function is most outer, the derivative encounters it first. Right? So sine squared pi theta. And all that is prime. So the power comes down. Right, differentiate the outer function. So the squaring function is outer, it comes down. And you lower the power by 1. The inner function, sine pi theta, stays the same. So it's now sine to the first power, pi theta. Then I complete the chain rule by taking the derivative of the inner function. The inner function at this moment was sine pi theta in totality, sine pi theta. So our derivative will be, at least in notation, that to complete chain rule. Okay, so we still take this derivative. So now the focus changes, and sine is now the outer function, and pi theta is the inner. So to complete this, we have 2 sine pi theta. The derivative of sine pi theta is going to be, sine becomes cosine. Again, that's outer right now, so I do outer first. Sine becomes cosine. Pi theta, the inner function, stays the same. And I take the derivative of pi theta. Pi is a constant, theta is the variable, so I just get pi. Right? So, but in notation, just firstly, I'll write it like this. I would still have to do that. Okay. But that's just going to be 2 sine pi theta cos pi theta, and then just pi. Okay, so we have the derivative completely taken. It doesn't look as nice as it could, but we do have the derivative. So now we'll go ahead and simplify a little bit. We could change 2 sine cos into a double angle formula, but I don't think that's that necessary. Let's just push the pi to the front to make it look neater. 2 pi sine pi theta cos pi theta.